Recording. All right, everybody.
I know they've been doing some work on it in the area, so.
All right. Welcome to Auth, Part 1.
And it was out all day on a Friday, not last Friday.
I don't think Lynn can hear me.
It was the Friday before.
All right. So, let's do a quick overview of what we're going to do in this Auth series. So, here's our next couple days. We want to be able to create users. We want to be able to tell whether or not somebody who says they're one of our users we created is actually who they say they are. And then we want to use that to say, only people we know can access this. We don't know you. So that's our 3 steps. And then we can break these down into some smaller pieces. And along the way, we're going to learn a little bit about the big 3. I just made up that term. Encoding, hashing, and encryption. This is our the cryptographic section of the course. So today, we're looking at creating new users in Rails and explaining how hashing works. So if we do our job correctly, everybody's going to be able to do this at the end of the lesson. So to create a new user in Rails, most of it is stuff we already know how to do. We're going to install Bcrypt, which kind of worked the same way as cores. We're just uncommenting a line in a gem file. That's it. We're going to create a route to create a user. There's nothing special about this. It doesn't even have to be called user, but it often is. Then we're going to create a controller to create a user. There's really nothing special with this either. And then, this is the only part that's different about this from what we already know how to do with CRUD, is we're going to create a user model with a secure password. That has some Rails magic in it. So, to start with, I want you to watch me do this. Don't follow along. You're going to get a chance to do that also. But to start with, oh shoot, I can't make that only take up half the screen. All right.
Is this process notably easier in Rails than it is in other backend languages?
Yeah, it is, but I'll show you how you do it in another backend language. I'll show you like an example in Node. It's not different. It's just more verbose in other backend languages, but it's otherwise kind of the same thing. And we've had like lots of students be able to confidently do this in Rails and then figure it out in like a couple hours in Node. So
yeah, that's kind of the
process.
That's kind of the jump that I was wondering about. So that's good.
Okay, so I'm going to Rails new API some auth project 1. All right, and then I'm going to go into this project, and if I look at step 1, I need to install Bcrypt. So what I'm going to do is go over to my gem file, and I'm going to look for Bcrypt. That's this line right here. All you got to do is uncomment it out. After you do that, bundle install. And there's Bcrypt. We got all our dependencies installed. Rock on. We're going to create a route to create a user. So I go over to my router. I do something like resources, users. Wait, it's resource. God, this is the fucking problem with teaching this program. I've written 5 languages in the last 3 days. Is it resource or resources? I think it's resources. All right, I'm gonna go with that. We'll find out pretty soon. And then we're going to only expose the create action. Then we're going to create a controller to create a user. So I'm going to Rails G controller users, plural.
Why just the controller?
What?
Why just the controller? Why not like a, Rails G resource or, model
Because I
or,
don't want to just scaffold out all the shit. We're doing this baby steps one at a time. There's
Okay.
nothing special that only doing the controller does other than let us work in very small steps.
okay.
So if I go over to this controller, I'm going to make a create action. And then I'm going to make a user with the thing that I get back. So I could say, all right, I want them to give me a username. And I want them to give me a password. And then I'll render JSON. Cool. Nothing special there. No magic. Lastly, we're going to create a user model with a secure password. This is where the magic comes in. So I'm going to make that model, Rails G model user. And in the model, I'm going to write has secure password. It's a macro. It's metaprogramming. This is like adder reader, adder accessor, the same kind of stuff as that. This turns into all the code we need to hash a password. Then, last step, I'm going to go over to the migration that it made. I'm going to make a string for their username. I'm going to make a string for their password underscore digest. That's also magic. I called it password when I'm sending it in. I'm calling it password digest in the database. Run the migration. We're done. That's it. Watch this. If I run this server, on 3000, I go over to Postman. And if I go to localhost 3000/users and I post a username and password, watch what happens. Makes my user record, and oh, I have a not plain text password that's in my database now. Ta-da! That's all you need to be able to do today. That's step one. Create a new user in Rails and explain how hashing works. Now, Kyle, what is hashing? Hashing is this. More specifically, this is a hash. So you've probably heard, because this is like stuff that even like regular folks know at this point, you don't want to store plain text passwords in a database. Why?
Because anybody can go in and read them.
True enough. Yeah, if you have like a rogue employee or someone who just wants to see everybody's passwords, select all from user. Done. Got everybody's passwords. Even worse, if it's a malicious actor, like somebody gets a hold of your database, like keeps fucking happening. It's like every couple months we had Home Depot, we had Experian, we have all these people get their databases compromised. If your password is in plain text in that database, yowza. Not only can they impersonate you on that site, if you reused that password anywhere, oops.
Like everybody and their mother does.
Correct. So we don't store plain text passwords. We store password hashes. So let's talk about what hashes are. I mentioned the big three, that term that I made up. Encoding, hashing, and encryption. These are three different things. Encoding is Pig Latin. Just as easy to do one way as it is another way. So we'll call this two-way. If I say ABC and we're using letter number substitution, and it goes in as 1, 2, 3. If you know I was using letter number substitution, it's not any harder to turn 1, 2, 3 back into ABC or ABC back into 1, 2, 3. Cool. Encryption is, so we'll call this symmetrical two-way. Encryption is asymmetrical two-way. I won't get too deep into it, but this uses math, and it uses a strange property of numbers that it is relatively easy to square something. It's relatively difficult to find something's square root. It's substantially harder to do this than it is to do this. So, relying on that property of numbers, we can make something that's relatively easy to go one way and very difficult to do the other way. And so that's the basis of encryption. We'll talk about that later in this series. But when we encrypt something, we lock it up real tight, and you really can't reverse it unless you have the key. If you have the key, you can do it pretty easily. So, also, if you're a math nerd, the exact thing at play here is you take two ginormous fucking prime numbers, you add them together, and then you square them. So the big crazy math thing that's happening is if you know what one of the prime numbers was, you can find that square root relatively easily. If you don't know what either of them are, you never fucking will. So, and if all that was gibberish to you, don't fucking worry about it. It's not important. All you really need to know is that this is just as easy to go one direction as the other. This one's much harder to go one direction than it is the other. Hashing, by contrast, is one way only. You cannot reverse a hash. Hashing is not a math term. Hashing is a breakfast term. The idea is if you take some potatoes and shave them up, throw them on a griddle, and you do some more potatoes, and you throw them on there, you kind of mix them all together, and you throw some more potatoes on there, and you mix them all together. You can't tell which potato any part of it came from. That's hashing. I'll give you an example. Let's say we do our letter number substitution with ABC. So if I store it like this, you can reverse that pretty easily. That's encoding. If I add those together, though, I get 6. That's a hash. The reason it goes one direction is you can't get ABC back from 6, because 6 could also be F. It could be the letter A 6 times. There's all kinds of different things that could be 6. So we'll call this Kyle's shitty hashing algorithm. So I don't think you have to use a whole lot of imagination to imagine a good hashing algorithm that generates great big giant numbers, that it's very unlikely that you would intentionally generate 2 different things with the same hash. In fact, that's what they measure the quality of a hashing algorithm off of. Is it possible to intentionally make 2 things with the same hash? As soon as somebody can do that, like once, they declare the algorithm dead and make a new one. It's happened like once in my career.
So it basically takes whatever the user inputs and puts it through at least to anybody looking from the outside, a random set of algorithms that just take chunks and change them.
Yep.
Okay.
And the output looks like this. Ask me some questions about hashing.
So there's something that's missing in my gap understanding somewhere. When the user comes back and they put in their same really crappy password,
Yep.
the program is able to recognize that password. So the program remembers or knows what the crappy password is, even though it's only going to show us the encrypted part. Where is the actual password being remembered at?
Oh, you're right there. So if I enter in Kyle, my Garbo password, and I hash it, I get this hash. So this is the thing that's actually stored in the database. The Kyle password, that's not stored in my database at all, anywhere. So when I'm trying to prove that I'm Kyle and I enter in my same shitty password, how does it know that it's me?
Does it hash it again and match it?
Yes! That's exactly what it does. When I enter in my same password, it's going to hash it again, and it's going to compare those 2 hashes. That way, my server never needs to know, or at least my database never needs to know what my password was. Only what it hashed into.
So I might be unclear on something, but I thought the generation of the hash was kind of a random event. So how do you know you're going to get the same thing each time you rehash it?
It's deterministic. It will always hash into the same thing.
Okay.
So like maybe K turns into $35X.
Correct. That's kind of the other magic of hashes, is my password could be 1 letter long and it could be a novel long. The hash is always the same size. You can't tell what the password, how long the password was from looking at the hash.
Okay, I may have an unclear understanding again, but if generating the hash is deterministic, how does that keep somebody from going backwards and being able to figure out what the original password was, if it's going to be the same thing every time?
You're beautiful. So, it's a great question. Now, like, if you just had a list of what everything hashed into, like, yeah, that'd be a problem. The problem is, like, I'm sorry, you're going to maintain a list of every single combination of characters and what their hashes are?
Okay.
Probably not. However, there's still a threat there. And that threat is opens up a vector called a frequency attack. And here's how it works. So you get Home Depot's database, and you notice that certain hashes show up a lot more than others. So this one shows up this many times, and this one shows up this many times, and this one shows up this many times. And so we get this frequency distribution of how often the exact same hash shows up in your database. And it ends up kind of looking like that. Can anybody see what the vector is yet?
Would the idea be like that really frequent one is the dumb shit that's using like password as their password?
Bingo. So if people are using the exact same password, then they get the exact same hash in the database. We have a list of the most commonly used passwords, so we can compare that frequency with this frequency and get a pretty damn good guess at what people's passwords are. Uh-oh, that's not good. This is like a slightly tricky one, but you could logic your way through it. So I'm not giving you a completely unfair question. How do you think we get around that? Think to yourself for like a minute, because it's a pretty interesting hack on how we can make two people with the exact same password have totally different hashes. Think to yourself for a minute. All right, any guesses?
I thought you would append like a unique username or email with the password to create the hash.
Oh, holy shit, you're like 80% of the way there. Yes, that's like essentially what you do. You append something else to the thing that they gave you and then hash that. So if my password was ABC, I add 9 to it and then hash that.
And your username would have to be unique, so you could always have like a little tag on that's...
Right. Here's the beauty of it though. We can just randomly generate it. Doesn't matter. Because we end up storing that plain bit of it with the hash. So take a look at that thing that came back from Postman again. There's a couple different parts to this. It doesn't look like it, but this first part here is the version of the algorithm, which is 2A, and the cost to it, which is 12. The like cryptography is always basically a race against how fast a cracker's computer is. So over time, you want to use a more expensive algorithm. And so this one, Bcrypt in particular, lets you control that. 12 is like basically everybody's default right now. Someday computers are going to get faster, and a better default will be 13. You can make it 20 if you want. The difference is that as that cost goes up, it just takes longer to generate the hash in the first place. So you could make a hash with a cost of 50 if you're okay with it taking 1.5 minutes to log in. But your computer gets faster, all right, well then it's faster to generate for the hashing process to happen. But like a cracker's computer is now also faster. There are, even with these like extra things that we're doing to prevent frequency attacks, if you give a computer long enough to run, it's still going to crack your password at some point. The difference is that we want that to happen on the order of hundreds and thousands and tens of thousands of years. So it's just not worth it for somebody. Because it's also not free to like run your computer for that long. So we want the cost to just not be worth it to somebody. Okay, so those are the first 2 bits of data that we have in here. The version of the algorithm, how expensive it is, and then these first few characters, I think it's like the first 6. That's a completely randomly generated collection of characters that's going to get added to the end of Kyle. So it'll end up being Kyle, IESPTA, and then we hash that, and the result is the rest of it. That's called salting, also a breakfast term.
Someone was hungry when they came up with this stuff.
Salting and hashing, that's what we're doing. And check it out. If I try to make another account with the exact same username and the exact same password, watch the password digest change. Totally different hash. You would have, if you got a hold of my database, you would have no clue that me and other Kyle have the exact same password. Cool.
So this is within Bcrypt. Is Bcrypt a Ruby thing, or is it a what?
It's a math thing.
Okay.
It is the current like most popular default hashing algorithm.
Okay. So
There's
other backends would use Bcrypt as well.
Yeah. So like Bcrypt is also the most popular one in Node, but it's describing the hashing process.
Okay, gotcha.
There's an earlier one called MD5. That's what like the standard was when I started. So MD5 came out in 1991. It was initially designed as a cryptographic hash, was found to suffer from extensive vulnerabilities. By the way, this is what professional mathematicians do for a living, is like come up with stuff like this. So in 2012, they found a vulnerability in it and exploited it. Unsuitable for further use.
And yet.
Still gets used. Yeah, by contrast, Bcrypt came out in 1999 and still going pretty strong.
So are there other suitable alternatives in case Bcrypt gets cracked, or if that happens, are we kind of up a creek for a little bit until someone else comes up with something else?
Oh no, there's tons of this shit.
Yeah.
If you're curious about how these work, if you go to my knowledge wiki, I have a description of how how hashing works. It's under security hashing. So this is a description of MD5. You start with like a standard binary pattern, and then you transpose stuff. And like the big magic on this is and, or, and not, the Boolean operations can't be reversed. So once you do that, you don't know what the previous thing was. There we go. Another place we use hashes, they get used all over the place. They're really handy. Check out. So I make a git commit here. And then take a look at my git log. Ta-da! That's a hash.
Woohoo.
So they're not just used for security, they're also really good for identifiers. Or if you've ever seen something that's like, verify this hash. Basically what they're doing is they run all of the like bytes of the file through a hashing algorithm and produce something that looks like this. If it was tampered with, it won't generate the same hash. So you know if something got tampered with. In the case of Git, it's just a way to do IDs. So even across different branches, even across different repos, the likelihood that two commits will have the exact same hash is like a space dust colliding kind of issue. It's intensely practical. It's saying it's technically possible that two of these things could have the same hash. Real fucking unlikely though. And so we're just going to lean on how unlikely that is. Very pragmatic kind of thing.
This is the same shit they're using in like URLs for like Google searches, YouTube, all that shit?
Yep.
Cool.
Although a lot of those are just GUIDs, which so like a lot of those are these. These are use pseudo-random number generators, PRNGs, and these aren't hashes. Like there wasn't something that was turned into this, that's hashing. These are just randomly generated, but there are so many of them that they're just statistically okay for use as IDs in databases. The chance that you using this tool and hitting refresh, that you and I are ever going to see the same ID, astronomically low. And so like I once built a video cataloging system, and instead of using database IDs, because like it was split across a bunch of different databases, and so you can have one thing that's in charge of assigning IDs to these, or you can just use some library that generates GUIDs or UUIDs and uses those as the unique identifier. And it's so rare that two things would have the same one that you can rely on that for uniqueness.
What is it, like ultra unique?
Universally unique identifier. GUID is globally unique identifier. I think globally unique identifier is like a trademark of Microsoft or something, but same idea.
So where is this like algorithm that hashes it kept?
Inside of the Bcrypt gem. And it's not a secret. Like all cryptographic algorithms are very public because professional mathematicians are always trying to find ways to break them. And there's even a law. It's like security law only need the key disclosure. Nope, that's a bad thing. Only decipher using the key. Shoot, it has a snappy name to it, but the idea is that you should be able to know everything about a cryptographic algorithm other than what the key that was used to generate it is, and not be able to break it. Which is why those fucking key disclosure laws or the federal government people who are like, you got to put security backdoors in. That's why that doesn't work. Because then you would need to know something other than the key. You could have a skeleton key. That's mathematically not possible to make something secure that way.
Yeah, that makes sense. Because like if something like this existed and it was all behind closed doors, and then someone found out it was stupid easy to like break it, yeah, that makes sense.
So Rails is open source, yeah? Which means Bcrypt is?
Mm-hmm.
So could somebody just like monkey with Bcrypt and be able to find out people's passwords that way if that's where the algorithm is stored?
Well, like, I can't push a change to Bcrypt. I can PR a change to Bcrypt, but Bcrypt is run by security researchers. So if I try to like weaken the security of it, they go, nice try, asshole, PR rejected. And actually, shit, the Bcrypt algorithm, that's not even run by security researchers. The algorithm is just math. The Bcrypt gem is people who took that formula and turned it into code.
How do you, this just going on that tangent a little further, how do you make money on something like that? I took somebody else's math, I made a gem, and now it's super popular. Is there anything to be made off of that, or just you get experience and you go like get a job because of your experience?
You put, I own the Bcrypt gem on your resume, and you make money that way.
Yeah.
Or you do speaking engagements, or you sell a book.
Yeah. Okay.
That's kind of the money making model behind all open source. Is it makes you famous in the community, and then you make money off of that.
Yeah, doesn't the Ruby guy, DHH, doesn't he like competitively race cars or something in some insane rich guy hobby?
Yes, he's also the CTO of Basecamp, but yeah, he doesn't make any money directly off of Rails. He makes a shit ton of money as the CTO of Basecamp and as the Rails god. He's got books. It costs a lot of money to get him to speak somewhere, all that kind of stuff. Ditto with like Yehuda Katz, who's a former Rails core team member and kind of like my patron saint of software development. He created Ember, he created Rust, he created Yarn, all kinds of cool stuff. To my knowledge, he's never made money off of any of that. But he runs a consultancy called Tilda, and I imagine a lot of the clients are like, you're the Rails guy and the Ember guy and the Yarn guy. Take our money, please. Make our software better. Other questions?
You said anybody could access like this code with the algorithm in it?
Yeah.
How? I Googled and I was not finding it. Oh, on our...
Yeah, it's installed on your computer. So if I go over to RVM, gems, I'm on 265, I think, right now. There's Bcrypt. Is that all of it? That might be all of it, yeah. There we go. There's the code. Oh, it's got some Java in it too. That's why it has to be, you're saying like building extensions or whatever. That part of it's written in Java. Oh, that looks like some cryptographic nonsense. There you go. Yep, there's the blowfish cipher. So yeah, if you want to study the encryption algorithm, there it is. Other questions?
Earlier you mentioned encryption and how it's generated from two huge prime numbers.
Correct.
Is the idea that like one party has one of those prime numbers and the other party has the other prime number, and that's how you decrypt?
Well, one party has both of them, and if you want, I'm getting ahead a little bit, but you can think of it as like a padlock that you leave open and give to somebody, except you have as many of these as you want. And other people can take your padlocks and lock something up with them. They can't undo them themselves, but like, why would they want to? If I'm sending somebody a secure message, I have the message and then I lock it up with the like open padlock you gave me, and then I give it to you. If it's intercepted in the process of me giving it to you, nobody else is going to be able to undo the lock. But since I have both the prime numbers, I can do it.
Okay.
Isn't that how they do like the secret Coke recipe? They hand out like certain people have it.
Something like that.
Can't be on the same plane or whatever.
All right, let's review the code. Step 1. I install Bcrypt. All that was uncommenting out that line and running bundle install. I created a route to create a user. Nothing special there. I created a controller to create a user. Also, nothing special there. I created a user model with a secure password. The magic in that was this phrase, has secure password. What that does is it translates the password they gave me into the password digest that it needs to be in the database. That whole conversion happens in the model. So then in my actual database table, it's called password digest, not password. And that's it.
So what is the connection between password digest and the hash? Is the password digest the hash? Okay.
Digest is another term for hash. Less breakfasty.
Can we do this in our terminal, like with shortcuts? Like, you know, we normally do like username, it defaults to string. Is there a way to do it with a password?
I'm sure. I don't know what it is, but I promise you there's a terminal shortcut for it. It doesn't have to be called password. It doesn't have to be called password digest, but you got to pass other arguments and shit to the has secure password macro. If you're okay with calling it password, then you get all this stuff for free. And I think there's a command line where to do that also. I don't know what it is though. Other questions about this process?
So you just said digest is just a naming convention. Even if you don't have digest, it'll still give you the hash because you said secure password.
No, this won't work. If I wanted to call it like passphrase digest or something like that, I think I have to say something like that. Don't quote me on that, but like that's an argument that you can pass in to the macro. If you don't do anything though, it expects it to be called password digest. Okay, your turn. So I want each and every one of you to give this a shot. There's the steps. I'm going to put 5 minutes on the clock. Give it a go. Go! me a quick visual sanity check. Fist to 5. Fist is what we're supposed to be doing. 5 is I got a hash coming back. Where we at? Cool. Let's review the code again one more time. Answer any questions. So step 1, adding bcrypt. Uncomment out that, run bundle and
Seeing the screen.
Oh, we can't see your screen.
Pew! Who the fuck want to see my screen anyway? There we go. Uncomment out bcrypt, run bundle install. That's step 0. We create a route for users. Create a controller for users with a create method. Nothing fancy there. Has secured passwords, what goes in the model. Password digest is what goes in the migration. Questions?
You do in fact go in and manually change that to password digest.
Yeah. So when you do the migration, it comes out like that. Here, watch. We do the entire thing over again. Watch how fast I can do this. It's like I've taught this lesson a few times before. I'm going to do Rails new -- API some auth project 2. Cool. So I go into some auth project 2. I go into my gem file. I uncomment out bcrypt. I bundle install. I make a controller for users. While I'm in here, may as well make the model. Cool. I go into my routes. Resources users. Solamente. Create. Go into the controller. Make a create method. A user is user create username. Password. Render JSON. Cool. I go into my model that has a secure password. By the way, if you ever forget that phrase, you go to the gem file. Hey, got it right there for you also. Then I go over to the migration. P.string username, P.string password address. I run Rails DB migrate. Serve it up, Chris. I'm about to. Run the server. Make a post request. Pew, pew, pew. So at the start of tomorrow's lesson, this is exactly what we're going to do. We're going to start by you on your own. We're going to do all these steps. And then we're going to talk about how on earth do I verify the password that somebody sends me hashes to the same thing that I have stored. Questions before we wrap? Wiggity, 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 whack. Cool. See y'all soon now.